All right, we are going over our mixed practice on systems of equations. Mind you, these are equations, not inequalities till tomorrow. This is Ms. Starling's paper, 7 period. Okay, so we're going to go over how to solve the problems, and then we'll solve them independently. So the first question states, the tables below list some ordered pairs for 2 linear equations. What is the solution to the system of equations represented by these tables? What will I do with these 2 tables? Put them where? In Desmos. And what's Desmos going to give me? The equation. How many? 2 equations. So I need a y equals and a y equals. And then once I have both of those equations, what am I going to do? Well, this is technically 1a. It graphs it for you. And what am I looking for on that graph? Where they intersect. So 1b, and this is my answer, is where they intersect. Number 2. Number 1's answer also is visibly written in the table. You really don't even have to do this, FYI. I'll let you pick up on that. Okay. Number 2. What is the solution to the system of equations represented by the graph shown and the equation? So how many things do I have here? I have 2 things. And this one, I had 2 things as well. And my answer is where they what? Where they intersect. So, for this first thing, what must I do here? No distribution because there's no parentheses. I've got to solve for y. After I solve for y, what will I have to do with this? I can't graph a graph.
Take some points. Make a table.
I have to go backwards, and I have to take my graph and make a table so that I can make a who? A slope-intercept form equation. So solve for y, make a table, graph both y's, or y equals mx plus b's, and then see where they what? Where they what? Intersect. Good. Okay, on number 3, trick question, but not really a trick. Will my steps here be different from these steps? No, because I'm still looking for a solution, right? And what's a solution? It's where they cross. Okay? So I would need to solve for who here? Y, which would be easy. All I need to do is do what? Who? Subtract 2x. Y equals negative 2x plus 6. Now this one requires a little bit more work, but I still need to solve for y by subtracting 5x and then dividing by whom? By 3. Not 3y, just 3. Okay? Then I graph y equals, and I see where they what? Intersect. Number 4. Okay, an alternative solution to this is elimination. Coach KB suggested that I take this whole equation here and I eliminate my y's by multiplying this by a negative 3. This was a 4-8 IXL lesson if you've already done it. Okay, if you like the elimination, it's easier in my opinion, as long as you know how to distribute. Here's the distribution, Ariana. So this is getting multiplied by -3. So is this, and this will be one of the rare times where I jump over the equal sign and distribute as well over to this 6. So -3 times 2 is -6 with an x. -3 times y is -3y, and -3 times 6 is -18. Then I bring this guy over, and I have 5x plus 3y equals 14. If you were paying attention to elimination before break, I can eliminate. Eliminate means get rid of my +3 and my -3 because they are opposing signs but the same coefficient. Then I can combine these. -6 plus 5, because this is a giant addition problem, is -x. And this is a giant addition problem over here. 18, -18 and +14 is -4. Then x equals 4 because I want this to be positive and this to be positive. So I found my x value, and then I can plug in to get the y. So it'll be 5 times 4 plus 3a tilde 14. Why did I change the y to an a? Because I'm putting it in Desmos. So this is an alternative for number 3. Number 4. I've got y equals 3x plus 11. Do I need to solve for y? Nope, already done for me. I've got x plus 2y equals -6. Do I need to solve for y there? Yes, solve for y. Once I found both y's, then I'm going to do what? Graph them where? In where? In Desmos. And then see where they what? Where they meet. Oh, let's sound mathy. Intersect. Number 5. It gives me a table here and a graph. Let's do the hard part first. Let's knock that out. What do I need to take from this graph? The y-intercept, always. That's the easiest point most of the time. xy is 0, who? 0, 3. Good. Now I need another friendly point on that line. -4 and 1. Sure. And then my table, xy, 0 and -7. And let's switch it up. First and last point, -5 and 3. Then what are my steps? Solve for y, then graph in Desmos, and then see where they intersect. Now number 6, I've got to build my system here, okay? I've got to build the equations as well. It says a church group ordered a total of 22 drinks and burgers. That is an equation there. They did not get just 22 burgers, y'all. I need you to understand that, okay? They got drinks and burgers. Do we know how many of each? No. So since we don't know, what do I need to apply? Who's the unknown? X and Y. X is my, what do I not know? My who? My drinks and my burgers. So X will be drinks. Y will be burgers. You can also use D and B, but I prefer X and Y. It just makes the most sense. Each drink costs $2.50 and each burger costs $6.25. If the group spent a total of $92.50, how many burgers did the group purchase? So not only do I have to create the system, but I've got to find the number of burgers. So let's continue Well, let's start writing the system first and foremost. So this first bubble is its own equation. How do I build an equation with drinks, burgers, and 22? X plus Y equals 22. Now, if I'm feeling extra fancy, what does Y equal? Because I have to get rid of the X anyway. What do? Subtract 2? Good. Minus X minus X. Y equals, I'm taking X away from my 22 drinks and burgers. Okay, that's one equation. The other, how much are those burgers? I'm sorry, the drinks. So I write 250 what? X. And how much are the burgers? Plus 625 what? Y. And it's going to equal 9250. I'm running into my other equation there. How would I solve for Y here? Minus 250x minus 250x. Who do I bring down? Good. 6 1/4. Y equals. Perfect. And then what else? Plus the 9250. Now what? Divide by 6 1/4. Divide by 6 1/4. Divide by 6 1/4. Okay, you should be able to finish from this step. You're looking for the burgers, which is my who value? Y value. Y equals the number of burgers. All right, let's go to number 8 real quick because I got to make an adjustment there. Number 8 says, where's my change? I need us to cross out a different dog, yada, yada, yada. And let's say a dog sitting service charges are shown in the table. This is the different dog sitting service where they charge $30 plus $7.75 per night or per day. And then this is another dog sitting service. So there's 2 dog sitting services, and I want to know after how many days will they have charged the same amount. So that's basically asking what is the solution to this system. What did I write down here? Which means I have to do what? How? How do I find Y? Put this in who? Desmos. And Y will give me an MX plus B. And I'll graph both and see where they do what? Intersect. Y equals, graph them. Find intersection. Back to 7. Oh, 7's easy. Y equals 2/3 X plus 1. Y equals negative X plus 4. What do? Desmos. Graph them, see where they do what? This should say -1. Oops. There's your system. Find where they intersect, an X and a Y.